We are asked to find all the values where the tangent line is horizontal for the function f of x equals x cubed minus 5x squared minus 6x plus 11. So the first thing is we need to find the derivative, which is pretty straightforward. We get 3x squared minus 10x minus 6. And since we're looking for a horizontal tangent line, that means I need to take the derivative and set it equal to 0. So at this point, we need to factor if it's factorable, but when you try factoring this quadratic, you find out it is not factorable. So whenever we have a quadratic that's not factorable, that means I need to use the quadratic formula. And if you remember, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac divided by 2a. And my a comes from my quadratic equation, which is 3. And let's see if I can clean that up just a little bit. Sorry, that doesn't look much like a 3. Okay, so this is 3. My b is negative 10, and my c is negative 6. So we're going to plug these values into our quadratic formula. I have x equals, well, negative 10 plus or minus square root of negative 10 squared minus 4 times a times c all over 2 times a. So x equals, well, negative 10 is going to be 10 plus or minus square root, well, I'm going to have 100, negative and a negative, plus 4 times 3 times 6 is 72 all over 2. And let me go ahead and give myself a little more space here. So now we're going to have x equals 10 plus or minus square root, and 100 plus 72 is 172 over 2. At this point, you need to look at what's under your radical, that square root of 172, and see if we can break that down into something that's a perfect square, and we can. It's 4 times 43. So we can simplify at this point. Well, I can do the square root of 4, which is 2. And then I'm left with the square root of 43 under the root, or the radical. And at this point, we can, on the numerator, we can factor out a 2. So that leaves me with 5 plus or minus square root of 43 all over 2. These two cancel, so my final answer will be 5 plus or minus square root of 43.